Yeah, I just do. All right, so going back, we have -1, -5, x is -1, y is -5. Find r by doing the square root of x squared plus y squared. So that's -1 squared plus -5 squared, which is 26 under the radical. And now we're here plugging in, trying to establish what our 6 trigonometric identities are. So we did y over r, -5 over the square root of 26, multiply top and bottom by the square root of 26 in order to rationalize our denominator. And we have our answer here, -5 square root of 26 over 26. Similarly, we do cosine x over r is -1 over square root of 26, multiply top and bottom by square root of 26. And that's negative square root of 26 over 26 for C, for cosine. Tangent of theta is going to be y over r. Excuse me, not y over r, y over x. Hold on 1 second. Sorry about that. All right. So here this is just -5 over -1, which is positive 5. And then cosecant. Cosecant is the inverse of sine. So that's square root of 26 over -5. Secant is the inverse of cosine. And then cotangent is the inverse of tangent. So those are your 6 trigonometric identities. All right, so questions on that? Make sure you're good.
Yep, I'm good.
All right. So the next one, it says, this is 47. I don't want to do circle. They give us tan theta is positive. You know, when it says greater than 0, that means it's positive. And secant theta is positive. Yep. So it's which quadrant is it in? So basically, this comes from let me see. All students. Dang, what was it? All students. I forgot what it is. I know I got it in my notes. Hold on a second. I'll try to remember it off top. I know when I remember the order because hold on. So got all sine 10. Because all students take calculus. Let me see if I got it right. Okay, so maybe it's no, it can't be 5. 7. How about 5, 3? Oh, a smart trick class. Oh, all students take calculus could be the same thing as well. But you see how In the first quadrant, all of your trig signs are positive. In the second quadrant, sine and cosecant are positive. Excuse me, sorry about that. Sine and cosecant are positive, thank you. In the third quadrant, tangent and cotangent positive. And then in the fourth quadrant, cosine and secant are positive. So one way you can remember it is a smart trig class. And I think I was thinking about calculus, a way to relate it to calculus. So that's why I said all students take calculus. But either way, you see ASTC. So all, sine, tangent, and cosine. Lets you know which, going counterclockwise, of course, which one of your trig functions are positive in which quadrant. So if we go back, so if tangent, tangent is positive, that means it only can be in this quadrant or this quadrant. If it's when secant is positive, it can only be in this quadrant or this quadrant, because secant is the inverse of cosine. So you see that it has to be the first quadrant where both of them are positive. All right. Questions on that? Make sure you're good.
Yep, I'm good.
All right. All right. So number 49. I'm going to find the exact value of the remaining trig identities. So to give us cosine theta is 2/5. Sine theta is negative. All right, so first thing we recognize is that we have 2/5. That means x is equal to 2, r is equal to 5, and y is unknown. So we need to solve for y. And of course we got that, just make sure we understand this is x and this is r. So r is always positive. So let's say if this was negative 2/5, that means that the 2 is negative and that r is positive. R is always positive. So any negative signs dealing with cosine or sine, cosine or sine would be assigned to that top number. All right, so we'll solve for y by doing or using the relationship here. All right, so that'll be 25 equal to 4 plus y squared minus 4. 21 is equal to y squared. Square root of both. Now, so we have to be careful here. Y is equal to, whenever you take the square root of both sides, that's plus or minus square root of 21. So now we need to figure out, is it going to be positive or negative? And so what's going to be the hint to that is going back to what we just did in that previous exercise. We see cosine is positive. So cosine is going to be positive in both of these quadrants. In this case, sine is negative. It did say less than, make sure. Yep, sine is negative. So that means you're talking about this quadrant and this quadrant. So we're talking about the fourth quadrant. And well, I guess we may not. I don't know. We'll see if we need that later. Anyway, but it tells us sine is negative. So really, because that said sine is negative, really, because it just went with this being negative. Because sine is negative in its fourth quadrant. I don't know. We might need that. I might be thinking about another type of problem. But either way. Since sine is negative, that means y has to be negative. So we have negative square root of 21 for y. All right. You know, we're in the fourth quadrant. Cosine positive, sine negative. All right, so now we can go ahead and plug in. We know cosine. We just need to know the rest of them. So sine is y over r. Negative square root of 21 over r, which was 5. Y over x. X was 2, right? Yep. And then cosecant, which is the inverse of sine. So multiply top and bottom by the square root of 21. Let's see, negative. And then we have secant, which is the inverse of cosine, which is 5 over 2. Yep, just making sure. And then cotangent, inverse of tangent. That's 2 over the negative square root of 21. Which would be negative 2 square root of 21 over 21. All right, questions? Any questions?
No, I'm following along.
All right. Find the exact value of each of the remaining trig functions. Okay, that's what we just did. Find the reference angle for each. So our reference angle, that's exact value. I know I just saw that. Even odd. That value might be 5.3. All right. So our reference angles, we let theta be a non-acute angle. That's if theta is a non-acute angle. In the standard position, that means lies in a quadrant. Its reference angle is the positive acute angle, theta prime. We call that theta prime, formed by the terminal side of theta and the x-axis. So here are your 3 ways you can have your reference angles right here. So now if it's acute, then you don't have a reference angle. That's what these, we talk about non-acute angles, they will have reference angles. So in this one, your reference angle will be formed with the terminal side and the left side of your horizontal axis. Same thing here, but on the other side of it. And then here on the other side of the right side of your horizontal axis. So it just depends on how far theta goes. Let's see, did I do a summary of it? Thought I did that. I must have left it out of these notes. All right, so let's look at, well, I guess we can just look at these problems right here. So if I have 345, 345 degrees, erase this right here. And I want to know the reference angle for it. I'm using my 360 degree angle in order to be able to establish what is this missing piece right here. So what you would do is subtract that 345 from 360, and that's how I got 15 degrees. So it's 15 degrees in this little spot right here between the terminal angle and that right side of your horizontal axis. So it always depends on, once again, where your theta, what angle, or not angle, what quadrant your theta ends up in. Oh no, what happened? 45. Oh, okay. Okay. So same thing with 5 pi over 6. Here what I did was I ended up converting it to degrees. Just to make sure people understood where we're coming from and how we got it. Let me see something real quick. Yeah. I'm about to say I thought that was the case. That has to be the bottom one. Where's the 160 come from? Okay, here it goes. Here goes B right here. I'm trying to figure out where I must have just been using 160 as an example. Okay, yeah, so that's what I did here. That 160 has nothing to do with B. I'll say because that's 150. But 160, I was saying if your angle was 160 and ends up being the second quadrant, then you would subtract it from 180. And so that means 20 degrees would be here. Then if your angle end up being in the third quadrant, that means you need to subtract 180 from it so that you see that you have 45 degrees in there. So once again, if it's in the fourth quadrant, you're subtracting that angle from 360. If it's in the second quadrant, you're subtracting the angle from 180. If it's in the third quadrant, you're subtracting 180 from that angle because you always want the positive angle. All right, questions on that before we look at it in radians?
Nope.
Okay. So if it's in radians, what I did was just to make a clean comparison, I will always find the decimal value because I know that pi is 3.14 and then dividing it by 2 is 1.57 and then 3 pi over 2 is like 2.71, I think, something like that. But it's 2.71. No, I mean 4 point something. Anyway, either way, I know that 5 pi over 6 is 2.62. So that puts us in the second quadrant, in between 1.57 and 3.14. And then I follow the same procedure I would as if it was in degrees. So I took 5 pi over 6 and I subtracted from pi. And that's 6 pi over pi, which is pi over 6 once you do your subtraction. All right. And same thing as if it was negative. That means we're going counterclockwise. And that puts me over here in this third quadrant. And then I just follow the same pattern of adding it to, because it's negative, we adding it to 180, to positive 180, so we can get that positive result for our reference angle. All right. So questions on reference angles? Sure.
No.
Okay. So let's see. All right, so now looking at 57 through 67, says find the exact value of each expression. Do not use a calculator. Is she or he allowing you to use a unit circle? What are you doing there? Did you have to commit some things to memory?
I'm not entirely sure.
Because you have the square root sine of 240. And then you're talking about using the reference angle. So this is 0, this is 90, 180, 270, and of course it's 360. So 240 is going to be over here. Hypotenuse. So the reference angle, theta prime, is going to be 240 minus 180, which is 60 degrees. So basically you're looking at sine of 60 degrees. But this only matters if you have committed the unit circle to memory, because we've already talked about, we already mentioned that all angles are positive here. Only sine is sine and its inverse, which is cosecant, are positive in the second quadrant. Cosine is positive here, and then tangent is positive here, and then cosine is positive here. So that means since we're in the third quadrant, we know that sine is going to be negative. But if you haven't committed sine of 60 degrees, at least this first quadrant, to memory, then this still doesn't help you. That's why I was asking you, did she even have the unit circle chart? Do you have the unit circle chart?
You said what now?
Do you have the unit circle chart?
Nah.
Okay, hold on. So, question. So how was he or she expecting you to come up with the exact answer? Did she tell you how? Or?
Not that I can remember, no. I don't quite remember going over this specific thing.
Gotcha. Well, this is the unit circle right here. You may have seen it before, but notice how, let me see, you are seeing my picture right here. So notice how when you look at quadrant 1, 30, 45, 60, all of these are reflected in each one of the quadrants, the coordinates. If you look at the coordinates, cube root of 3 over 2, 1/2, square root, I said cube root, square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, 1/2, square root of 3 over 2. And then that's reflected in all of these other quadrants. Well, the reason why the reference angle is so important is because if you can remember this first quadrant, then you know the rest of them. You just have to remember, in the third quadrant, X is negative and Y is negative, your coordinates. In the second quadrant, X is negative, but Y is positive. And then in the fourth quadrant, X is positive, but Y is negative. That just flows with your X, Y Cartesian coordinate plane. So that's nothing different. You just have to remember, these coordinates right here. So now our reference angle is 60. So that's right here. And so the coordinates are going to be 1/2 and square root of 3 over 2. And that's what's right here. And then in that quadrant, we know that X is negative and Y is negative. So that's why our answer would be, and so you notice right here, 240. But that's why our answer would be negative 1/2 over 2. Negative 1/2 and then square root of 3, negative square root of 3 over 2. And so that's why you're supposed to be leaning on the reference angle relationship, because your reference angles are going to be 60, 45, or 30. And then from there, each one of those relationships are reflected in the other quadrants. And then all you have to do is remember how the signs work in each quadrant. All right. So you want me to send you a copy of this? Or do you not need it?
Yeah, that would be great.
Okay. So I have to go to my next class.
All right.
Did you still want to meet after that class?
Yeah, I can do that.
Okay. And also looking at number 60. Never mind, that's a part of the last set of directions. Okay. Okay, cool. All right. So yeah, I will send you this chart and send you a copy of what we talked about up to this point, and then try to link up with you a little bit later. Now, you said you had a test on this tomorrow?
Yeah, I have a quiz on this.
Okay. Man, why you waiting till today, man? You could have.
You see, I didn't know I was going back in person today, so I thought I'd have more time to
Oh.
Yeah.
Oh, okay. Because I'm about to say we just came out of the weekend, man. We could have found some time. But All right, I'll try to link up with you a little bit later.
All right.
All
Peace.
right, man. Take care.